The next topic is to solve linear systems using substitution. So I can graph the two lines, and that's one way to solve. The second way is to do this algebraically. So if I look at these two equations, you'll notice they say y is 4x and y is also negative 6x minus 30. So since I already have two values for y, I can take that y I circled out and substitute what it equals to above. Okay, so I'm going to take out the y and put the 4x in its place. So I end up with 4x equals negative 6x minus 30. So this is substitution, replacing something. Now I can draw my t and solve. So plus 6x, 10x equals negative 30. Divide by 10, and x equals negative 3. So I found an x value, but I'm not quite done because I have to find an intersection, a point. So right now I have that x value, but I also need to find the y value. So in order to find the y, I can pick either equation. So we have two to pick from. We have y equals 4x, okay? And you also have y equals negative 6x minus 30. And you only have to do this one time. I usually pick the one that I find to be the easier equation or less steps. So for example, for this particular problem, I would substitute x into that equation because I only have to multiply by 4. So I can do y equals 4 times negative 3, which is negative 12. And I have a y. Now, just for the sake of showing you, it really does not matter which equation I put it in. Say I take the x and I choose to use this second equation here. So I'm going to put the x in there. So I would end up doing negative 6 times negative 3 minus 30, which gives me 18 minus 30. And the answer to that is also negative 12. So it's a way I can check. I only have to pick one of them, like I said, to find my second point. So I'll put an or here. And now I have my intersection point. So if I graph these lines, they should intersect at negative 3, negative 12. And verify. And yes, my solution is correct. Okay. Let's do one more. Okay, so the next problem is y equals negative 5x minus 10 and y equals negative 10x. So I'm going to replace that y with what y equals. This time I'm going to write it out for you a different way. So you'll notice I have y here. Since y equals negative 10x, I'm going to put negative 10x in for y. I'm going to erase y and put the negative 10x in its place. Now at this point I can drop my t and solve. So plus 5x to both sides, negative 5x equals negative 10, divide by negative 5, and x equals 2. So now I have the x coordinate. Now I have to find the y coordinate. It does not matter which equation you use. I'm going to use the second one. And now I'm going to replace the x right there with the 2. So y equals negative 10 times 2. Y equals negative 20. So now I have my 2 coordinates, which are 2 and negative 20. So 2, negative 20. And that's where my 2 equations would intersect. Now, just to show you, if I actually graph these 2 lines right here, they should cross at 2, negative 20. So if you want to see, I'm going to graph them using GeoGebra. Otherwise, you can stop this video. Okay, so I'm going to the graphing calculator, and I'm going to graph y equals negative 5x minus 10. I could graph this on paper also. And the second equation, which is y equals negative 10x. My dog was just laying on my keyboard. Lincoln. And typed in all those zeros. And I can see I have the 2 lines. And I'm looking for where they intersect, which you'll notice is right down here. Okay. And if I zoom in, you will see that that is 2, 1, 2 over, and negative 20. I'm obviously boring Lincoln because he's over here yawning. Okay, so that matches our answer that we got, to negative 20. And that's it with systems of equations. Now you'll be able to graph and find the intersection, and you can also use substitution.